Conversion of polar to Cartesian and vice versa. Last day I wrote you the formula that if a point is there, suppose x comma y, then in the polar coordinate it will be written as r cos theta comma r sin theta. Okay, last day we did this. Let us do a quick revision on this. What is polar, what is Cartesian? Yes. Yeah, we need a straight line. Yeah, after this the color should be white, and another from here, this way. Yes, yes. Now see here, this is our graph. Okay, this is y coordinate, this is x coordinate. Now a point is there, suppose, where here there is a point, the point P whose coordinates are x and y. Okay, so therefore cannot it be straight ever? Okay, nothing can be done. Okay, let's delete it just. Yeah, now, yeah, nothing can be done. And another from here. Well, let them delete it. Delete everything. Creating problems. Now, this is our point x comma y. Oh no. Now, the lines travel straight through here, down to there. Yes, and the one from here to here. Now, this is our x part, this is our y part. Okay, and a line going through the middle of it to this point is our R. Okay, so this is a right angle triangle. This part is theta actually. Yes, therefore, what is the polar coordinate of x comma y? The polar coordinate of x comma y is r comma theta, where r is the hypotenuse, therefore r equals root over of x square plus y square. Yes, done. Now, how do we convert this? Now, conversion from r theta to x comma y. How can we convert? Yes, na? To convert it, see here, what is sine theta? Sine theta is our perpendicular by hypotenuse. What is the perpendicular? Here, the perpendicular is y by hypotenuse is r equals y by r. Therefore, y equals r sine theta. Yes. What is cos theta? Cos theta equals base. The base is here x by r, x by r, which implies base x equals r cos theta. Therefore, we can write x comma y as is just equivalent to r cos theta, comma, r sin theta. So this is our conversion from Cartesian, yes, from polar to Cartesian, yes. Actually, let it not write it like that. It should be r comma theta. R comma theta is just this, and which is just equivalent to x comma x, okay, x comma y. Now it's perfect. Understood? Yes. Now let's do some problems. Problems such as find, sorry, convert the Cartesian to polar coordinates or vice versa. Okay, this is the question. How can I do it? To do first question. 5,53 degree. Don't worry. The 2 number question is 2,60 degree, and the 3 number question is 1,90 degree. Yes, let's first of all do them, then we'll do the rest. 5,53. You know, this important term. We know the values of some, such as sine 0 is 0, sine 30 is what, half, sine 45 is 1 by root 2, sine 60 is root 3 by 2, sine 90 is what? It is 1. Then the cos theta is just reverse from here to here. There it will be cos 0, cos 30, cos 45, cos 60, cos 90. Yes. And then dividing them, we get the tan theta. In addition to all this, we need another value of 53 degree and 37 degree. That is very important. That one is, this should be what? This r, here r is 5 and theta is 53 degree. You know, therefore 5,53 degree is just equivalent to r cos theta, comma r sin theta, equals, what is the value of, sorry, it is 5 cos 53 degree. What is the value of cos 53? See here, I am writing it here. Sin 53 is 4 by 5 and cos 53 is always 3 by 5. You know, just remember it. It is very important. Yes? Just remember it. Let me keep it a bit side or we won't be able to do problems. Go there. Yes. Remember it. 5 comma, what is the value of cos 53? Cos 53 is 3 by 5. 5 into sin 53, 4 by 5. Then the value 5 cancels, 5 cancels. It comes as 3 comma 4. Yes. First conversion. The second one, 2 comma 60 degree. R equals 2, theta equals 60 degree. Then 2 comma 60 is just equivalent to, I'm writing it direct, 2 cos 60 comma 2 sin 60. What is the value of cos 60? Cos 60 values as half and sin 60 values as root 3 by 2. 2 to cancels, 2 to cancels here, which equals 1 comma root 3. Second question done. Third one, 1 comma 90 degree. R equals 1, theta equals 90 degree. So 1 comma 90, I'm writing it now again. 1 cos, okay, no need to write 1 actually. It should be like cos theta comma sin theta. What is the value of sin 90? Cos 90 values as what? 0. And sin 90 values as 1, 0 comma 1. Yes? Perfect? Alright. Yes? Now the other changes are simpler as well. If you write 3 comma 4, then what you have to do is we need to just draw the diagram. Yes? Draw the diagram like this. Plot the point 3 comma 4. Then do sin theta cos theta. Sin theta values come something. Yes. 4 by 3 comes, sorry. 3 by 5 comes, we know that theta equals 53 degrees. Yes? 4 by 5, I'm correct. Theta equals 53 degrees. That's how we have to do them. Reverse. Now I'm not doing it because we have other things to do also. Done. Now next part is more formulae. We have more formula. Last year we discussed the distance formula. What is the distance formula? Remember? Let me write it again. The distance formula is distance formula. Distance is root over of x2 minus x1 the whole square plus y2 minus y1 the whole square. This is the distance formula. For any 2 points, for any 2 points x1 comma y1 and x2 comma y2. Yes? Yes? Distance formula done. Today we'll do a new formula which is named as section formula. Section formula. What is section formula? From the name, we can understand that it describes about sections. A line is divided into sections. Let's see how. Section formula like a line is there. Dotted line. Most probably that is straight or that. Yeah, now that's straight. Most probably, I don't know. It should be straight line. Okay, and there are 2 points here. A, it has coordinates x1 comma y1. There's point B, it has coordinates x2 comma y2, x2 comma y2, and there is also a C coordinate in the between, not in the between exact, somewhere around x3 comma y3. And the line is divided, sectioned in the ratio m by n. Yes? So what is the coordinate of C? C coordinate is defined as m into b and n into a. How? M capital B plus n capital A whole divided by m plus n. Now it doesn't make any sense. How can I just multiply them? It's in a way that x3 comma y3 is equivalent to m into x2 comma y2 plus n into x1 comma y1 whole divided by m plus n. But you can't divide them. Why? We have to do it in the way that it should be mx2. mx2, just add the x to the x and y to the y. Okay, this is like vector. You have not done most probably. In a vector, only same directions can be added. You know na, the basic of vector. This is the basic of vector. Therefore, we can add only x direction with x direction, then y direction with y direction. Simple, quick, easy. Yes, m plus n it should be. Yes. So this is a section formula. We'll do the proof later on in our next class only. Okay. Now see. Let's move some triangular problems. Suppose a triangle is given. Actually, not equilateral triangle. I'm not wanting an equilateral one. Can I draw any other type of triangle? No, it's not giving any options. Okay, let this be a triangle. Yes, and 2 points are here. Okay, 2 points are here. What is this? A and B. Okay, A, B. Let it be a scaling one. Okay, it has points x1, y1. It has points x2, y2. Sorry. There is a point in the mid. That is C, x3, y3. So what is the coordinate of C? Okay, let the coordinate be not given. What is the coordinate? It should be like that. C is just equivalent to. What does it mean to be equal? It means this is also 1, this is also 1. It should be 1 into B, that is B, B plus A whole divided by 1 plus 1, 2. Yeah, it means x1 plus, sorry, comma y1 plus x2 comma y2 whole divided by 2. We add the x values and we add the y values, then we can get just C. Suppose these coordinates are 2, 3, 4, 6. Okay. Now what will you do? We'll do x1. What is x1? 2. The coordinate is 2, 3 plus it should be 4, 6, 4, 6 whole divided by 2. At the x values 4 plus 2, 6. 6, 3 plus 6, 9. Then divide both of them by 2 separately. It becomes 3, 9 by 2. That's how we write the coordinates. Yes, simple. These are my special case of sector formula. Next day, we'll discuss many problems about them. We'll discuss some problems also. And along with that, we'll discuss about centroid formula, in center formula, then 9-point circle, and many more. Today up to this, thank you, have a nice day.